short introduction, our next presenter is Bob Flynn, and he will be speaking about cloud computing at IU.
Have you seen this box thing? Look, I was able to preview my slides coming out here.
Oh,
like box, you should check it out.
You know, I've used it.
Really?
Yeah, just a few times.
Sweet. Hey, everybody. Thanks for having me out here again. I still have the water, still trying not to cough. I'm here to represent the massive cloud technology support team. Oh, wait, I've got the clicker too here somewhere. All right, here we go. I even got my cloud socks on today for the presentation. All right, so is anybody here currently using cloud technology? All right, we got one, we got a couple in the room. Oh, awesome, none of my images are on the slides. That could be problematic for this talk. Hey guys, can you bring up my slides in box? They probably are fine there. I will describe what images you should be seeing. This really could be a problem. All right, so there's a picture of somebody holding a smartphone. So imagine that, and you have been using cloud technology for a long time with your smartphone. Obviously they are powerful computers, but not all of that computing is happening there. Image here of lots of computers. So basically, what makes it the cloud is leveraging computing at scale. So Gmail is probably running more than one server to run your mail. So that's the kind of scale we're talking about. Remotely distributing those resources to endpoints, fancy graphic of computer pushing out to various other devices. Maybe I should have done the interpretive dance version of this presentation. So where is the cloud? And these were some of the best pictures here. So under someone's desk, imagine messy office with server under desk. It could also be in your local machine room. Imagine local machine room, you know, a couple of racks and stuff. And then, and we'll see here, man, they didn't get this stuff working. So there was audio in here too. And this is supposed to be a little puppy dog because those first two examples are kind of the pet model of computing. So you name your servers in your machine room, you know, Manny, Mo, and Jack, or the Twin Towers, or something like that. So that's the pet model where you're attached to it. It could be a VM at the IU data center. Imagine big row of computers. That is an image from the IU data center. Or it could be a massive Google data center. Imagine about 50 big rows of computers. And then, oh, we got one of the audio sounds anyway. That's a cow. This is the cattle model of computing, not the pet model of computing. With cattle, you don't give them names usually, unless it's a pet cow, I guess. So what's all the hubbub about cloud computing? Finally, we've gotten to a slide with no pictures, so we'll just roll with this one. So scalability, it allows you to do computing at scale. Again, what you can't do on your device alone, you have many computers in the background helping you scale. Measurability, so you can measure every little compute cycle, crank it out to Splunk or other measuring tools built into the cloud stack. Efficiency, you can program apps so that they only use the compute cycles they need. You're never over-provisioned. You can even program apps to use compute cycles only when the overall scale of computing is at a lull and drops below a certain point. So like, I only want to compute when it costs me 5 cents an hour to do it. That kind of thing. Reliability. Imagine 11 nines of uptime. That's the general average for, say, an Amazon Web Services. Recoverability. Coming a little bit back to the cattle model. You build your images so you build them to die, is how somebody put it to me once. You want it so that if the thing dies, it knows to come right back up. Or if it has to scale, it knows to come up and start running right away. You just build in a different way. And it allows you to focus very specifically on your spot in the computing stack. So if you're a programmer, you don't have to worry about servers, that sort of thing. You just do your programming at that spot in the stack. What does that make it good for? Disaster recovery, business continuity planning. So you can create servers that the moment they come down for whatever reason, a clone pops up seconds later so that your service keeps going. Unpredictable loads, one of my favorite stories. I have a colleague out at Caltech. They're one of the main research universities around earthquakes. And earthquakes are, I think most people would say, are fairly unpredictable events. So what would happen is when there would be an earthquake, everybody would rush to Caltech's website because they wanted to see the stats, the media wanted to find an expert to talk about the event that just happened. And so what would this result in? Their website would crash, right? All of a sudden, it was just taken down by too much traffic. Well, then they moved to the cloud. You set a few rules, like whenever the CPU hits 50%, clone yourself, do dynamic load balancing, and off you go, and scale as much as you need to, and then when the load goes back down to 5%, then start to kill off those cattle back down to the original server. So that kind of unpredictable load. Auto-scaling of applications. If anybody's familiar with the broadcast application that is written into Canvas, it allows a faculty member to go in and identify a folder and box and say, I want all the students in my class to have a copy of this folder. It does some little magic shell game on the back end. Everybody gets their own copy in their box account. Well, you know, for 20 students in a class, who knows? It might take 30 seconds, a minute, I don't know how long. But K201 over here at the business school, 2,000 students in the class. So do you make the faculty member sit there and tap his foot while it runs through 2,000 students? No, the app just clones itself 10 times, 100 times, and it takes just as long. Low-risk dev and test. I was at a conference last year where they had a guy up who led development at some company. I don't know, it was not a startup, but a big company. And he said that his developers go through 1,000 VMs a week. They just burn them. They just burn through them. Test some code, spin up a server, put it on there, run it for 5 minutes, run it for an hour, whatever you need, then it's gone. Who cares? So it allows you to create an environment like that to where you're just using the compute you need. And then it allows you to get things out quicker to market. You're not like going on eBay and ordering servers, then waiting for them to be delivered and putting them in and all of that. You can be up and running quickly and get your things out quickly. All right, you can do, you fill in the blank as a service. Losing my earpiece here. Software as a service, we're familiar with things like Box, Canvas, Qualtrics, Duo, LastPass, all software as a service. Platform as a service. Again, talking about that developer who just wants his database, he wants his messaging service, that sort of thing, but he doesn't want to deal with having to stand up a server to run those things. That's the platform as a service level. And then, of course, infrastructure as a service, running the actual VMs. Extreme computing. Imagine, coming back to the scale question, at Amazon Web Services, you can spin up a VM with up to 2 terabytes of memory. Imagine the computing you can do with that. So those are some of the things you can do. Here you're going to imagine an image of a forklift coming in. Lift and shift is one way to get your stuff into the cloud, and that is basically, I have a server here, I'm going to run it over here, and you don't refactor anything, you just move it. No, I'm good, I got a bottle of water. Thank you, Karen. It may sound like I need a drink, but it's not water. All right. What's another way to get in the cloud? Re-architecting. Here I have this classic drawing of an architect at a big architect's board. Your imaginations are just abuzz right now. This is the way you want to move into the cloud. And that is you have to take the way your applications have been before, and you kind of have to sweep it off the table and rebuild them using the tools as they're intended. And this was a great quote that somebody from another institution who's a little further on the cloud spectrum than IU said, we've turned our developers into financial engineers as well. They create very efficient applications so that they can use the least compute necessary. Remember back in the day when application developers worried about space and memory in their apps? Hopefully they still do, but not so much. Imagine a graphic of an abacus here. That's what I had. All right. Options available to you at IU today. We'll see how this slide works. Not at all. That would not be good. All right. There's a graphic here of a ladder going up, and it has 4 clouds up the ladder. The one at the top says cloud first. Oh, no, that's the next slide. Oh, man, I just gave it away. All right, so options available to you here at IU. We have intelligent infrastructure in the data center and smart services, which are roughly equivalent to platform as a service. Other people take care of your servers, that sort of thing. You can just do the work on top of those. Microsoft Azure and AWS, Amazon Web Services, also available at IU today. We're just putting our toe in that water. We just started provisioning Azure accounts this past week. And as soon as we finish our single sign-on integration, we'll be doing the same with Amazon Web Services. And then this one, I kid you, this is not a joke. This came real from Tally Thatcher in purchasing. Joe's Data Center. Faculty member at a school in Indianapolis, which I will not name, didn't want to go in the IU Data Center, so he signed up with Joe's Data Center. Come on down, folks. Put your data in my data center. All right, and I had a graphic, actually Joe's logo I had to add to this slide too, but not a good idea. All right, click. I guess we missed the slide with the clouds. What I was going to say, so I'm going to go back to that before I run down the list here. So at the top of that ladder was cloud first, and I would say IU is kind of cloud first at the SaaS level, software as a service. So we're looking, before we build something, we look to see if there's something out there that we can get as a service. Then the next one down is opportunistic cloud. And that is, we are taking advantage of the cloud where it makes sense for us, and that's kind of where we're at with platform as a service. And then below that is opportunistic, experimental cloud. And see, that's why I need the pictures. I don't always remember this stuff. Experimental cloud is kind of where we are at infrastructure as a service. And then below that still is cloud aware. You know it's out there. And that's what hopefully at the end of this talk you all will be, is cloud aware. So some considerations, cost. They're giving me the music. All right, so with the, thank you. It's a payback for taking all my images out. All right, so if we're looking at on-prem with II and smart services versus the public cloud versus Joe's Data Center, cost, you have the ability to control those things and look at competitive cost. Flexibility, you have a number of tools available to you. I'm not really sure about Joe's Data Center in that equation. Scaling, definitely you can scale, auto-scale, those sorts of things in these options. Again, Joe's Data Center, your mileage may vary. Click, support. Oh, and maintenance, and I didn't get those are 2 praying hands on the maintenance there for Joe's Data Center, so the image is just not with me today. And portability, all right, I'm getting the shepherd's crook here. Portability, there's a Docker conversation tomorrow to tell you about how to create portable applications that you can move from one environment to another, including here at the data center, so go listen to the one about Docker tomorrow. Security, definitely in the first 2, not so sure about the last. And approved use, don't make me laugh for Joe's Data Center, but if you have approval from the data stewards, then you can certainly use your applications in those 2 environments. So the last thing, this was the cloud. This is the latter one. We're skipping that. So come learn with us if you're interested. Kill your pets. Oh man, There's a big tombstone with Fluffy's name on it here. And that's what we're losing by not having images. And then this last one's probably not going to work either. So, oh. All right, wait. There he goes. Raise some cattle. And there was a whole herd of cattle going across the screen here with the sounds of a stampede. So they totally eviscerated my presentation, but I hope you got something out of it. Thank you very much. I could show you on my phone. It works there.
Thanks, Bob.